so back talking about section 10.3, we're talking about compound interest now. So in the first video, we introduced what compound interest is, how it's repeatedly adding in interest along to your principal, and that the longer the time goes, the more impact you're going to see on that. So we did a few problems on the last video where it was straightforward, where you knew the principal, you knew the rate, you knew how it was compounded, and you knew the time. So what we're going to do in these next few examples is, I guess next two examples, we don't know the principal, we know what it grows to. So if you haven't already, read example 4 where it says that we're wanting to kind of project, we need $30,000 in 6 years, so how much needs to be invested today to make that happen? So if you know, like in the future, there's a certain number that you'd like to get to, how much do you need to have today? And again, we wouldn't absolutely know what the interest rates maybe were going to be, but we could do an estimate and do some figuring to get some ideas. So in number 4, please do read that. We've got Will Hunting, who would like his daughter to attend college in 6 years when she finishes high school. Will would like to invest enough money in a CD now to pay for his daughter's college expenses. If Will estimates he's going to need in the future, so over here on this side of the formula, he needs to accumulate to $30,000. How much does he need today? How much principal should he start with? So we've switched it up there. So notice from the reading, this is the future value. We don't know the present or the principal to start with. We do know everything else. It gave us 4.72%, so we changed that to the decimal anytime we put it in the formula by going to left. And then it's compounded quarterly, which we know means a 4 for the end value. When it says quarterly, put in a 4. And then 6 years, we've got to work on this. All right, so all of these are really an exercise in making your calculator. Once you get it in there, you just need to make your calculator cooperate. So we're going to be dividing. All of this calculation, whatever all of this chunk is, that calculation is going to divide, because when you have a variable times something, we have to divide that to each side to finish and solve for P. So you want to get that calculation off of your calculator, and then divide it to the other side. So I want to talk to you about that, how that can be sometimes another thing about our calculator that can give us some help. So I want to talk to you about that. If you type all that in on your calculator, again, you might need a parenthesis around that, unless your calculator superscripts it in some way to highlight it as an exponent. You need to tell your calculator that is a set, or go ahead and just call it 24. Then you'll be safe. So type that away. That should come out to be about 1.0118. No, wait a minute. And then raise to the 24th, which comes out to be, 1.325171885. Your calculator has 10 digits in it. Now, if you're not going to keep that number perfected in your calculator, which that's what I recommend, keep that, never hit erase of that. Just keep that in your calculator. And then dividing that to each side, whatever amount of places you're thinking of, just to demonstrate that. But try to keep it in your calculator in its most perfect form, and then do 30,000 divided by, pull up the last calculation, which is the ANS button. If you have that button, most calculators do. It's a second function over the minus sign. So if you can do 30,000 divided by, and then have your calculator pull up the last answer with all 10 digits shown, it'll be the most perfect answer you can get. You won't have round off error. So that's what I recommend. Now, if you hate that, or you don't have that button, or you'd rather just see the numbers, don't round it just like 3 places. Keep like 5 anyway. 5, I can't guarantee it because it depends on the numbers and the calculations and all. But probably you're safe with 5 digits, 5 places after the decimal. So I would recommend keep at least 5 though. If you're going to do any rounding, try to keep a lot of places. The very final answer may say round to the tenths or hundredths, but you can't round that closely in the preliminary steps. That is the last step, rounding. So rounding can get you in trouble. You can miss some pennies. I call that, you miss it by a few pennies on the computer and it'll count it all wrong. So do be careful with your rounding. All right, so when you do that on your calculator, checking your work, it should give you 2,200. Wait a minute, that must not be right. It must have been 22,000. I'll have to look at my calculation there. All right, I wrote it down. I know that's wrong. If y'all ever see any mistakes, I've mentioned this before, please do send me an email or let me know so I know to revise it. I'd hate to have wrong information out here for you that I didn't realize. Okay, it should be 20, I just have my decimal off. 2, 2, 6, 3, 8, and 60 cents is what I have there, 60 cents. I'm going to double check that I didn't have round off myself, so hang on there with me for just a minute while I check my work. I try to have my answer written down to save y'all a little time. And then 30,000 divided by answer. Okay, oh, it's 57 cents. I was worrying that I was off by some of those pennies I mentioned. To be most exact, if you have enough places, and the first time I did it, I only used the 5 decimals. I thought that was safe on this, but because the numbers were so big, I was off by 3 cents. Just to note that can happen. I was off by 3 pennies when I just used 5 places, so you might have to use 6 or 7. And like I said, it's best to use the full 10 digits to be on the safe side. But anyway, the final answer, $22,638.57 will turn into $30,000. If you had that on today and you invested it, and that's a pretty low interest rate really, but it's probably a fixed, safe interest rate, safe investment for 6 years. But notice you do make some money. You make about $7,500 off of your money investing, so it's always better to go in the positive way. Okay, looking at the next one, we have another example similar to that to practice. We have, we need $7,500 in the future, or $75,000, sorry, $75,000. How much would we have to invest today to make that happen? If it's at 4% and compounded semi-annually means use 2 for N, and we leave it there for 5 years. All right, so we're going to type that in our calculator. That comes out to be about 1.21899, but like I discussed earlier, try not to round off any at all because you can miss it by a few pennies, and that's frustrating. I know you all know that when you're using that math program, it's only programmed to be right at the penny, so that will be an issue when you're doing that. So I do apologize. I know that's frustrating, but try to keep that as exact as you can. Keep 9 or 10 digits or all of it in your calculator. Do 75,000 divided by that last complete answer. This one comes out to be 61,526 and 12 cents. So if you had $61,526.12 in the bank at 4% for 5 years, it would grow to 75,000. That's pretty cool. All right, let's see. Last part on this page says, say you want to save $5,000 as a down payment on a house and you only have $4,000 currently. How long would you need to leave the money in an account at 5% to make this happen and compounded monthly? So in this problem, we want to have $5,000. We currently have $4,000. Let's see, we know the rate. Let's see, the rate was given, wasn't it? It's 5%. It said compound it monthly, and the thing it left out was T on this. So whenever we're doing algebra problems, they can leave out different parts of a formula. They can leave out any one piece of this puzzle, and we could do our algebra skills, work backwards, and solve it. This will actually be something that you would do in a different class, though. We won't go that far, but no, that's stuff you can figure out. The formula would help us figure out time. How long does it take $4,000 to turn into $5,000? So that's a challenge question if you want to look at that and you want to ask me about it later, but we will not be responsible for doing that in this class. We're not asked to do that. The only thing we're asked to do is find A when you know all of this, or find P when you know everything except P, like we did in the last example. All right, so just to pique your curiosity about other ways we could use the formula. Lastly, the last page says determining effective yield, effective annual yield. I don't know if you've ever been in the bank and noticed sometimes they'll have a sign that says effective annual yield. They do this, effective annual percentage rate, APR, and they'll say the effective in front of it. Maybe kind of look for that at your bank next time. But how they figure out the effective annual yield, and I've got it listed for you here, is you just do $1, just because it doesn't matter what the principal is when we're figuring out this rate. It's going to be the same whether it's $1 or $1 million, the rate that we're figuring out. So you just do it with $1, and you do that for 1 year, and then figure out how much your money grows, how much your dollar grows, and that will help you figure out the percentage. So looking at number 6, it says determine the effective annual yield for $1 invested for 1 year at 4.75 compounded monthly. So we do A will equal $1 for our principal. The rate, they do need to tell you that. And how it's compounded, this one's monthly, so we'll use a 12. And we leave it in there for 1 year. So that's how we do all these calculations. If it says effective annual yield, you'd $1 for 1 year. Fill in your rate and how it's compounded. So we crunch that on our calculator. And it comes out to be this. A little over $1. So your dollar, this is what it accumulates to. Your dollar became $1 and basically a little over 4 cents. So let's take our dollar back off. That's how much we started with, and see how much of it's just growth there. So we grew a little over 4 cents, and to express that as a percent, we'll move to right and call that 4.85, whatever we're rounding to. Let's round to 2 places on these to be a little more accurate. So that would be 4.85%. And notice it was a 4.75%. Effective yield's always going to be a little better whenever you crunch this in. The effective yield, $1 for 1 year. All right, another example 7, we just do this again. Effective yield means do your formula with $1 for P, fill in whatever interest rate they say. It says 3% on this. It says semi-annually, so we use a 2 for semi-annually for here and here, and then we do 1 year. So we type this on our calculator, and we get 1.030225. Again, check your calculation. So to figure out the percentage that we grew it by, we take our dollar back off. So dollar was how much was put in the bank. So take your dollar back off to see how much of it was pure growth. And so our dollar grew to $1 and a little over 3 cents. So to make that into a percent, again, take your dollar off and then move to right. It's 3.0255. Repeating to the nearest tenth or hundredths place. If we're going to do hundredths, I think I've got 0, 2. Oh, there should be another 2 there. 2, 2, 5, 5. I forgot my 2 on that. So going over to make it into the percent, and then hundredths place, the 2 after will not round that up, so we would say to the nearest hundredth of a percent, 3.02. So again, it was just a 3% rate. The effective yield is always just a tiny bit, little bit better than what it is stated in the regular way. So that's how we do effective yield. As always reach out to me if you want to see further examples, or if you see anything in the videos, you can say, I need more of that, or I need you to explain why you did this, or maybe I made a mistake, so that could happen. So please do reach out to me anytime that you have questions. All right, best wishes.